Welcome, everyone. Thank you for joining. Today, we have this meetup and conference about search here from our offices at Empathy. We have René Kriegler from OpenSource Connection, and also we have Pablo Cañal, Backend Engineer from Empathy. Let me just introduce you very quickly who we are, what we do here. So this is our offices, actually. This is where we are right now. We are from Empathy. We do this wonderful ethical discovery, but we also have a powered motive. So if you have a small or medium business, you may want to check out. And also we are very much tackling the industry on the ethical commerce alliance approach. We actually hosted yesterday a super wonderful event in London on the ethical commerce alliance. So we rock it out. Check our website, Empathy, Motive, and Ethical Alliance, and also our engineering blog has a lot of interesting inputs there from our team. So I will just hand it over to René. René Kriegler is the Director of E-commerce in OpenSource Connections. He's been in the search business for over 16 years, and he will today give us a new vision on how to incorporate to search new technologies such as AI or vector search. So I'll just handle the stage to René, and hope you like it. We will have Pablo later on giving us another talk on privacy and search related to it. So that's all. I don't want to steal the show.
Okay, thank you. Vision sounds quite a lot. Yeah, I think I don't want to share a vision, but provide a bit of a perspective and a path on how we can approach and understand these new technologies. Thank you for the kind introduction, and thank you for having me at this meetup. Maybe to add to what I'm doing, at OpenSource Connections, I work as Director e-commerce search. As I've worked in this domain for a long time, I'm also organizing an event just related to e-commerce search. It's called MySys, Mixed Camp E-commerce Search. For those who work in the domain, you're very welcome to Berlin on the 21st of June. You can sign up now, and it's a free event right after Berlin Buzzwords. My technological background is in open source technologies for search, like Solr, Elasticsearch, Lucene, and I maintain a library for query rewriting called Quirky. I mentioned Quirky later on. So I said I come from OpenSource Connections. So what we do is we empower search teams and work with clients around the world. We do this empowerment through several means. So obviously we do consulting. We help the teams become better at search, teach them how to fish, so to say. The other aspect of what we're doing is trainings. Search relevance trainings or training or understanding the search result quality, how to measure it, and so on. And last but not least, we support the community by events like Haystack. There's a search relevance Slack that's highlighted here that I can't recommend enough. More than 4,000 people there discussing matters related to search relevance, and occasionally we write books and we maintain a few search related open source libraries. The topic of this talk is centered around this question: how can we deal with all those evolving technologies in search? And we're actually living in very exciting times. Lots of opportunities out there, lots of new things being announced every day. And at the core of this is that artificial intelligence now seems to be ubiquitous, and it seems to become a commodity, something that we can just plug in and use. This is really exciting. Yeah? So at the center of it are those large language models that allow us to use generative AI, generate language, generate content. This is kind of disruptive for our times. There's also one aspect related to search, approximate nearest neighbor search, and so searching the vector space. fast enough. And this has become available for us also as a technology. So it's become feasible now to do this even at scale. Yet another aspect that is really exciting is the availability of pre-trained models. So we can just use a model instead of training a model for ages and then fine-tune the model. And last but not least, there are a lot of companies out there now that provide new services, new platforms, vector databases that we can use as a service. So this is really exciting. And then it's an evolving market. Yeah, so venture capital pouring into it, everyone searching for their new spot in the market. So it's a really exciting time. Related to search, I think I want to highlight basically two things. So one is the semantic aspect of the retrieval. So instead of searching by keyword, we try to search by meaning. And that's a huge game changer, I think. And we'll come back to this a bit later. And then the other aspect, I think, that is related to search, maybe a bit more vaguely, is the aspect of conversational AI. That means instead of just running a search, we get into a conversation to retrieve information and to shape an opinion on things. In this talk, I mainly focus on vector search and on large language model powered chatbots and how we can approach them. So with all this nice opportunities, if we go to in the wild, if we go to see actual search teams, we see a huge buzz, but very little adoption. Yeah, so at the moment, I think some of you might not even see this. You have to take off your glasses, right? So, so the community is full of buzz around and excitement about the opportunity, but not many teams have applied these new technologies. Yeah, and why is that? Yeah, so on the one hand side, we think we have all those solutions and these great opportunities. And then on the other side, the adoption is so low, but we face this kind of fear of missing out. Yeah, so the new technology sounds promising, but where am I in this field? Yeah, so what can we do about it? And finally, it boils down to the problem, what user problem does this new technology solve? Yeah, so we don't get away just by replacing the way we do things. It's more about changing what we actually do. Yeah, so that's what the new technology should give us. And this is where the greatest opportunity is here. And I think this is the most important question. So when we try to cope with these new technologies, when we try to understand them and apply them in our domain, it's not so much about swapping one old technology for the new technology. It's really about thinking this user problem and how we solve this with the new technology, or what are the new problems that we can solve now that we had not been able to solve before. And that makes it difficult, and that slows down this adoption rate. Yeah, and we have to find a way to deal with this. Those who have been on one of our trainings might know this big picture diagram. So when we deal with search, usually the way we work in search is by this kind of cycle, the search experimentation cycle. So we have a variant in production, a variant of our system. Then we collect feedback either from the online users or through subject matter experts. We come up with an idea of how to improve it, and then deploy a new experiment. And then the experiment has to be accountable to the business. Yeah, so we have a kind of a contract where we say this experiment shall improve conversion rate or whatever it is by that percentage. And this is how we measure our experiment. And this is how we are usually thinking about this. In this new world, I think to approach it, this cycle has to be modified a bit. Yeah, so if we really want to figure out how these new technologies can help us in this new space, we have to start to become more open-minded. Yeah, so our experiments are not about squeezing out 0.1% of conversion rate. Well, this is helpful. This is the ultimate goal, but we have to discover how the new technologies can be applied to help the user better. And that could be through completely different means. Yeah, so the application of the technologies is different from what we had done before. And that means we have to formulate our experiments more towards UX, towards the user problem and the problem they want to solve in the real world, so that we can discover how the new technologies can help them with this. And we need to experiment quickly. Yeah? So we have to explore the space of solutions that is available now. So we can't spend too much time on just one idea. So we have to really run many experiments. And then our question in the end is about, did our experiment generate a UX insight? Yeah, so it's in the first place, it's not so much at this moment, what is the business outcome? Yeah, it's about this kind of opening the perspective of applying the new technologies. So basically, we are changing how our system works, how our search system works, and how the users interact with this. So this requires this greater degree of experimentation. Let's look at chatbots. Some of you might know that I like this slide. So if you think about chatbots and some folks telling us, oh, you could use a chatbot to find a product on site, online shop. What we usually do online is we follow a process to decide upon a purchase. Yeah, and the marketing is a well-researched process, the consumer buying decision process. So it starts with problem recognition. So I realize I need a certain thing, or I have a problem needs fixing. And then I gather information, evaluate alternatives, buy this product or that, take a purchase decision, and then there's some post-purchase behavior. The usual point where users come online and use search in this buying decision process is rather late. Yeah, so we might start gathering information, talking to people offline, thinking about stuff, get inspiration from friends. And then we have a certain opinion already, at least for most websites. This is what we hear from a number of brands. Then it's a bit later that we take this process online. So the online shopping happens here at this later stage, and search kicks in oftentimes even later, closer to the evaluation of alternatives and the purchase decision. So where could chatbots come in this game? So chatbots, I think, would have two uses related to search. So they can help us when we don't know what to look for, what to search for. Yeah, they can help us when we don't know how to solve our problem. Or they help us when we don't know how to search. Yeah, so we can describe the problem more verbally, and we might not be able to emit keywords and put them into this search box. So this is where where chatbots could help us. But usually this is at a very early stage. So we would not know these things, how to search for something or what to search for when we are at these earlier stages of the buying decision process. So there is a bit of discrepancy where chatbots would kick in versus where users would come online to shop online. And that might make things a bit difficult to apply these chatbots. But we might be clever. We might find a way to figure out how it could still work for the user. The second aspect is related to the conversational user experience. So if you look at this, so this is a screenshot taken from an announcement of Zalando. And we have to be fair, it's an announcement. This is not their final version of the chatbot. So they're working on this. And let's look at this chatbot. So basically, here's some guidance and AI-powered assistance to help the users find, I think it's something on a wedding, on a beach. What should the user wear for this wedding? And if you compare this to the standard search, we would find that this is a higher effort than we usually have in search. Yeah, so why is this a higher effort? So there's a greater mental load in the sense that I would use different things compared to search. When I search, I just think about the keyword. So that's basically a short cognitive effort. But then most of what I do in search is visual or motorical. Yeah? So I move my hand just to click. Yeah? And clicking is a lot easier, or perceiving visuals is a lot easier than typing in what I want. Yeah? And at some point here, the chatbot says, how about the color? Or have a color in mind. Yeah, have a color in mind. So I'm supposed to type in the color name. Yeah? So that's usually not how I would like to interact with the system. Usually I would like to click on a color or just pick from the color from the products that were shown. Yeah? And the other problem here is at least they figured out that it's worthwhile to show products in between here. But the chatbots usually just show a few products, yeah, like 5 or 10. Yeah, the same for the chatbot from Shopify. If you go, they have this in production. If you go to shop.ai, you can try this out. Shopify just shows 5 products here. Yeah, so what we are used, especially in fashion, to browse maybe 50, 40 results visually just from the images. And this is a much lower cognitive load that we have in traditional e-commerce search. So we have to be really clever to figure out how we can make this easy. Yeah, so what would be the benefit of using a chatbot? So there could be a benefit if the chatbot is like an assistant that knows me really well and that can help me with phases where I don't really know what I'm doing or what I should do, let's put it like this. So that requires a lot more attention to the UX. So coming back to the experimentation, if we just said, oh, let's create a use case for the chatbot and do an A/B test with that, we'll probably fail. Yeah, we cannot just integrate the technology. We really have to think about the user interaction. Yeah, and so the focus shifts a bit. Yeah, so the solutions are provided in the space of technology, and that's great and exciting. But to make it successful, we have to look at the user interaction at this place. Let's look at vector search. How can vector search help us? And I talk a bit more about vector search later on, what it actually is, and I will also demo it. But basically, let's think about a search that is not just based on keywords, but that's more semantically and more forgiving in terms of typos. So what we do here is we would slightly expand our known scope. Yeah, we would add a few features maybe for the user, but not as perceivable as before. Yeah, so search might just become a bit more convenient for the user once we apply vector search. And I want to go through vector search a bit more in greater detail to illustrate this and then illustrate how you can approach it. So for this part, I'm using a few slides from my colleague, Atita Arora, who gave a talk at Haystack on Tour in Krakow, and it's also available as video. It's a really nice talk. So what is vector search? Traditional search would say, we have a search index, and the search index has our keyword, and then a posting list of documents that contain that keyword. Yeah? And then we retrieve all the documents and apply some scoring and so on. Vector search does not depend on keywords. What it would do is it would map the queries and the documents into a vector space, and usually a high dimensional vector space. And the cool thing about it is that it would map things of similar semantics into the same corner of the vector space. So we try to illustrate this in this example. So you will see that at the bottom right, everything is electronics, yeah, and then at the top we have the bags, and then on the left we have kids related stuff, yeah, and then we have a carry bag for babies, yeah, and basically this carry bag is located between the bags and the kid stuff, the toys, yeah. So you can imagine it like this: things that belong together are in the middle. And then in the early days of embeddings, we had all those examples where you could subtract one thing from the other and end up with a new thing. Yeah, so king minus man plus woman equals queen. Yeah, so that was the old example there, I think. You get the idea. Yeah, suddenly we have a kind of spatial mapping of the semantics. And if we do this, we can easily overcome a lot of issues that we have with a traditional search. So for instance, long tail queries that often yield 0 results, not many results. And we might not have that exact thing in our index, but it might also be triggered by typos or variation in spelling. But as soon as we can create a vector for this thing and map it to the space, we might not match the exact same thing, but we might find something similar. Yeah? Or the synonyms. Yeah? So we might not have maintained our list of synonyms, but our synonyms might be represented in our model. And if you take a pre-trained model, it's very likely that it knows all the synonyms. And then just look into the same corner of the vector space for synonymous keywords. So this helps us avoiding 0 result situations. And there's also a way, and I show an example later on, to use this and exploit this for multilingual search. Yeah, you could imagine that we use the word in Spanish, the word in English, and the words with the same semantics are mapped to the same vector. So then it's pretty easy, kind of, to match using a different language. And last but not least, and that's a really cool feature, we cannot do this only for languages. We can also do this with images. Yeah, so if we recognize what's in the image, we can create a vector for this. We can map it to the same corner of that vector space, like we do for the textual representations. And suddenly we end up using multimodal search. And this is a very cool feature to exploit. So if you think about experiments that we could do for vector search, I want to go to this list of search passes. Yeah, so that could give us an inspiration where this could kick in. So quite a number of teams implement search so that they try out several strategies, several search passes to find results. And it could start with an exact keyword lookup, and if I don't find anything, I apply spelling correction, and then I find something, or I don't. If I don't find, I apply query relaxation. So that means if I have multiple keywords, I drop one and then find something, and then I might have 0 results. I give up, more or less. And our vector search could still be applied here. Yeah, so we could try it out. If you have 0 results, we could say we bring back something using vectors, vectorizing our queries after having vectorized our documents and try to find something by matching these two. So that might be the greatest opportunity for a first experiment. Yeah? Add this additional search pass and try to find further results. And then you would tell the user, we couldn't find anything for your original query, but you might still be interested in these results, better than showing nothing. Yeah? So The problem with this might be in the UX. Yeah, so we might not be able to explain the results that we find now at this very end. And then how would the user continue from this point? Yeah, so let's say if we have a spelling correction or query relaxation, we could tell the user a query that we search for, and then the user could modify this query and go from there. If we use vector search, we can't do this. Yeah? There are approaches to bring back queries in kinds of using vectors to find queries that would then be searched, and that could be explained. Yeah? So we would have to look into this and experiment with this, but it's still the most interesting starting point. I would say in the long run, we could also try to replace the earlier search passes using vector search. So we could say, oh, query relaxation, just use vector search, or spelling correction. This is one area where vector search works nicely. Try to replace this and maybe even replace the first search pass. The problem with this is usually or mostly related to UX, yeah, so explainability of what we did. Why do we do this? Why do we get this match? Then we need to combine our result or our retrieval approach with non-semantic result quality criteria. So what does it mean? So it's not just about the relevance to match a, let's say, laptop with a laptop. It's about bringing the best laptops or the best smartphones, whatever the query is, to the top. Yeah, this is not a semantic question. This is about user preferences, price and delivery time, this type of thing, those quality criteria. So we have to find a model how we combine the vectors with these things. And last but not least, if we apply a vector search, we would do a k-nearest neighbor search. So we would say, oh, bring back those results, like the top 100 around this query. And you could always bring back 100. Yeah, so it just says nearest neighbor. It doesn't mean how, it doesn't have a threshold to tell us how near, how close our neighbors are. Yeah, so that has impact on facet counts or overall result counts. So we would have to look into this in greater detail. Searchandizing is another aspect that we would have to mix in. So how do I push certain results? So how does this combine with the vector-based retrieval? And last but not least, there could also be legal issues. I know, at least in Germany, if you search for a certain brand and bring back results from a competitor's brand, you might get into trouble. Yeah, so there's a lot of considerations, but I think in the end, this would be the most interesting, the easiest starting point, and would have a great impact. Yeah, because zero results is still an issue for many sites. Okay, nevertheless, I would say in terms of importance, the learning at this stage is more important than the actual KPI improvement. And we want to know how this technology can be applied. Now that's the goal of our experiments. Of course, we don't want to destroy things. Yeah, so we have to keep an eye on the KPIs and ultimately improving them. That's the goal. But at this stage, the learning is important. So I want to show a route how to get started with vector search. Usually you would implement a minimal experiment, and that could even be offline to get a first impression how it works, a POC. And obviously you would not train your own model. You could just use your own vector model. You could just use an off-the-shelf model. Yeah, so go to Hugging Face. There are a lot of there's a huge directory of models or other sources where you can find these, and leave this idea of fine-tuning and retraining the models for later. Yeah, you just want to replace the zero results. Yeah, so you could do this right now, and then look at the simplest possible technology to actually apply vectors. Yeah, so the choice usually is, do I use vectors inside the technologies that I know, Solr, Elasticsearch, OpenSearch, or do I go to a specific vector database and then put all my data there, vectorize them there. There could be either option, or either option could be the better option. But if you have a chance to stay with Solr, Elastic, Lucene, this might be your familiar environment. That might be easier and also allow for better integration with facets and so on. Compared to using an external vector database. The downside of doing this is you have to index the vector, so your vector size would grow, and also the machines might not be the best suitable machines for doing vector matching. Yeah, so usually this is slower in terms of performance compared to the specialized vector databases. On the other hand, your not sending all your traffic from the beginning there, but start with the zero result searches, which is just a fraction of your traffic. So maybe that's helpful. All right. At OC, we maintain not just us, but we are, I think, main maintainer kind of an e-commerce template application as open source. It's called Chorus. And we added vectors to this. And what we thought is you could use Chorus, kind of a template to get started with vectors, and then apply the idea to your own search application. So the idea would be, how do I get started? I get started quickly using the template. I want to say a few words about Chorus. So Chorus comes as a set of Docker images, and the Docker components or the Docker images represent several components that build a vector e-commerce search. So you have a search engine, either Solr or Elasticsearch, and then a UI for Solr. This is Blacklight, and the UI is somehow generated using Blacklight. And it represents an online shop and the electronics domain. Then we use Quirky for query rewriting, so apply rules like they are laid out on this slide. Smoothie to maintain those rules, so rules for boosting, for synonyms, and so on, filtering dependent on the query. And then Cupid as a relevance judging tool. And then rated ranking evaluator is a library that calculates search metrics based on judgments. And that makes this Chorus ensemble. Yeah? So that's basically the library, the tool. And then we thought, okay, let's add vectors to it. So I want to demo Chorus using vectors versus keywords. And so this is the API. The data is based on IceCat data. So IceCat is a data provider. And as I said, it's mainly electronics. And I first start with a completely untuned version of default EDIS max search. My query is laptop, and the results look pretty bad. I get back a lot of accessories. I think this is a common problem in e-commerce. Accessories come back before the main thing. And if you look at the number of search results, laptop, I only have 184 results. The problem is there's a synonym missing, and in this data set, they standardized and called everything a notebook. Yeah, so if I search for notebook, I also get back accessories, but I get back a lot more. And if I scroll down enough, I find some true laptop computers. So let's start and use vector search. And we added a little box here that helps you choose the algorithm. And I just want to match by the text vector. And if I search for notebook now, I get back notebooks, a few accessories. So I used a model that was trained for text. Now let's look at the laptop query, the one that was missing the synonym, and I get back laptops now. Yeah, so without any human interaction, just based on the vectors, I could match the two. And the vectors were based on text. I now do the same based on an image model. So that means we index the vectors for the images in our data set. And then at query time, we map the textual query to the same vector space. And if we do this, it looks pretty good. So that is basically the idea, how it works. We could also say we retrieve by the keyword and boost by the vectors. Yeah, so just use the similarity, the cosine similarity or Euclidean similarity between the two vectors, the document and the query vector, and boost by them. I want to show some more capabilities, but also issues. So that was, I matched by image, the query laptop. And let me do this by notebook, or searching for notebook. And you see what I get back. I get back the stationary notebooks. And this is the correct answer, at least in the English-speaking world. In the UK, I don't know, also in the US, my colleagues tell me this is what they would expect. That means the model was trained with a kind of a cultural bias. Yeah? So someone used mainly English data to train this, and I used English as a query language, so it's fine. The thing is, this model is multilingual, yeah, so that could also have been a German query. We would say notebook in German, I guess same in Spanish. So when we retrain the model, we would try to get rid of those biases. If you want to have the devices at the top, I would have to tell this our training, tell this to the model during our training, and get rid of those biases. I want to show that this model is multilingual. So I use the German word for mouse, yeah, and I get back the computer mice. I think the Spanish word is ratinho. Okay, what is it? T-O-N, like this? Fingers crossed. Yeah, kind of, yeah. I tried ratinho. I don't know why I thought ratinho. It worked pretty nicely. So I don't know which language this is, whether this is a word at all, but it brings back the computer mice. I don't know what it is. But you get it that this is trained on more than one language. So if I use this French word for computer, I get back computer-related stuff. Yeah, so somehow we have this capability, and that's pretty cool. Yeah, so we don't have to translate our data. We would still have to translate the data maybe for display, so that the user can decide whether this is a valid match or not. Yeah, so the product description still would need to be translated, but at least we would have an easier starting point. Coming back to cultural biases, and I don't know whether they are good or bad. So the system is able to interpret the semantics of the query. So I could say toy for boy. Yeah, so and I would get back these examples here. Boys brush their teeth, of course, yes, and play with computers. But overall, I think that's acceptable. And then for the girls, we would get back red items, dolls, yeah. So that's this cultural aspect is kind of trained into implemented and in the model, and this can be either a good thing or not. Yeah, so depending on how much you want to have that. One more thing I want to show is a misspelling example, and so toner cartridge mistyped and still a phrase. So this is a pretty messed up query that I got from my colleague Atita. Pretty cool query. So this is the weirdest users who would search like this. Let's see what we get back. So I'm searching in images and it finds Lexmark stuff. Yeah, so it corrected the brand name, it corrected cartridge. So this is pretty cool. Yeah. And there are more cases. Yeah, so we could say a coffee maker with one F, and from a brand called Krupp, but the brand is called Krupps. It looks like this is really made to help us with long tail queries. Yeah, so the queries that we usually struggle with. So I think a good idea would be to try this out in this on those later search passes. All right, I want to give a few more details, share a few more details, but just a few on the implementation. So how did we implement this in Chorus? So obviously we have to encode the documents or encode the content of the documents into vectors. And we are using two models, so one for the images and one for the text. So for the images, we just use clip. It's a very common model for this, and it has 768 dimensions. And for the text, we use mini-LM, which has fewer dimensions. Yeah. And so we do this encoding, we store the vectors in the index, and then at query time, so the query comes in, and we use Quirky, the rewriting library, to change the query. So to replace, so in the matching case, to replace the query text with the vector. And to do this, in Quirky, we go to an encoding service because the models are usually available best for Python, or the most easiest for Python, and then get the encoding back and change the query so that we add the encoding. Oh, and in one case we just added so that we boost. So the boosting is a part of Quirky, in the other case, for the matching, we would replace the textual query with the vector query. And under the hood, then later on, it's translated into a Lucene dense vector query. Okay, dense vector. All right, so I think you get the idea, and it looks like you can easily get started with this. And then when you start thinking about it, start experimenting with this, all the questions will come. Yeah, so how do we do this? How do we do that? So I've already mentioned, so we have to think about what happens if we always bring back K results, yeah, K nearest neighbors. What impact is there on the result counts, but also on the search result quality? Yeah, sometimes people look at the cutoff similarity. So I say maybe once the similarity drops below, let's say 0.6, 0.7, I do no longer show the results. That could be an approach, though it's not exactly a metric if you use a cosine. Another question that comes up, how do we solve ID searches? Yeah, so what would be the vector representation of a search that is just an ID, a query that's just an ID? Obviously, we don't want to use vectors for this. Yeah, so we can, if we can, we should recognize the ID before we hand the query over to vector search. So there should be some kind of query intent detection before the vector search, or fine-tuning a vector model helps a bit with IDs, I think, but that's something we need to deal with it. So, and then we have to think about our domain specifics, yeah, like the notebook example. If we are in a culture or a language environment where notebook really means the electronic device, then we have to fix that, and that would require another retraining. Answering the question how we can combine vector search with manual search indicing, tuning, optimizing queries using rules. That's pretty easy to solve in Quirky. So in Quirky, we could still apply the rules before we go to the vectors. But we have to think about it overall. And do we have to give precedence if someone applies a synonym to what the vectors do? Yeah, so there's still some questions to be answered. Or if you use hybrid search, when we boost by the vectors and retrieve by the keywords. If there's a human who wants to apply a boost rule, we have to give precedence to this, I think. And then the last question is, how do we integrate signals from user behavior? So I mentioned earlier, we might have some preferences for certain brands. So this is not reflected in our semantics. So what would the model look like when we start integrating this? Yeah, but maybe you can tell the two things apart for now. Just focus on the semantics, focus on this easy use case and the experimentation, and then look at how we can do this later. And I think that's the end of my talk. Thanks.
Thank you. Thank you, René, very much. Do we have any questions for René? I'll hand over the microphone to you, so don't be shy. Okay. We have one question. There you go.
Well, first of all, thank you for the talk. Really interesting. My question is more like your opinion on the subject, because I know that you were talking about all the experimentation that we can do with this vector search. I understand and I agree with the point that the best starting point for this is like the no results. It's something that we can improve and we can get some value early in the experimentation. But how do you see, or which is your opinion about the long term? One of the buzzwords that is right now on the market is hybrid search. How do you feel, particularly on e-commerce, that's gonna work? Is it gonna replace keyword search, or how do you think it should be kind of balanced?
So, I mean, the term hybrid search basically implies it won't replace. Yeah, so we still have a part that is keyword based, and I want to point out that in last year's track competition, so track is an organization that evaluates retrieval systems. Some colleagues of mine participated using hybrid search for retrieving podcast transcripts, and they basically succeeded and won, I think, one of the competitions by combining keyword-based retrieval and then boosting by the vectors. Now they tried all the combinations, just vector retrieval, just keyword, retrieve on vectors, boost by keyword, and vice versa. So I said I think, because there were many evaluations, and I think they've won part of this. So overall, I think there is a value in it, and what I think I hear a number of times is it doesn't really matter how bad our models are. Actually, someone said so when I gave this talk in Charlottesville in the US, and I've heard this from other folks. It doesn't really matter how bad our models are. As soon as I combine models, the results become better. And I think what the reason for this could be is that when we combine them, we especially deal with like outlier cases, yeah, where one model does something crazy, something unwanted, or even cases like our accessories. In those cases, the other model, so to say, that is part of the combination would kick in and so that's my idea about it. And I think this will become a standard way of doing things. In e-commerce, I think the most promising resource for me would be to signals from images. And why is that? So textual descriptions seem to be noisy at times, and images, just take a picture. I mean, they still have a kind of a message they convey, but the kind of facts that we search for are somehow conveyed in the image easily. And I've worked on this in the past, given a talk on using image recognition for ranking, and at Haystack 5 years ago. What I could see there is that this easily helped with this accessory problem. Yeah, so at the time there weren't these large language models weren't available. So at the time, even smaller models helped this approach be on par with the simple or with the standard textual models. Yeah, so I would look into images. It becomes even more important in domains where you have little control over your content. So like user-generated content, they put all types of things into, or not, into the textual description, but then the images will be very, they usually don't lie.
Thank you very much for the question and the great explanation, René. Thank you. Do we have any other questions in the room? I don't see any questions on the remote connected people. So I think we would just give another applause to René and thank him for the great talk. All right. Well, I would like to add also that I believe for all of us at Empathy, it does resonate a lot because we do have several projects already in flight very related to vector search. And actually, our Chief Experience Officer, Borja Santaolalla, will participate on a webinar next Thursday, the 25th, on this topic and others like AI deep learning and some of the use cases that we're already experiencing or exploring nowadays. So it's pretty interesting. Check that out in our LinkedIn page for the invite. And now we are switching to the next presenter, Pablo Cañal. Pablo Cañal is one of our backend engineers here at Empathy. Also, he's one of our DevRel. So check out our Twitch channel so you will see him doing game very frequently. And he will continue a little bit on the privacy and sustainability topics that we are very keen on at Empathy. So he will talk about balancing privacy and personalization in the search experience. So that's all. Thank you very much. Great applause for Pablo, and let's go for it. Thank you.
Okay, thank you all, and thank you for the introduction, David. I was going to introduce myself in the next slide, but that was awesome. So I don't think I need to introduce myself now. So okay, welcome everybody, and welcome to the folks that we have in the remote session. My name is Pablo, and I'm going to talk about this brief session regarding balancing privacy and personalization in search experiences. So I think I can skip this now. Okay, I've been working in several projects, and some of them were more related to search, some of them were more related to privacy, to innovation, and all of that. So yeah, I think that we can start. First of all, I would like to start by making you think about this question, about what do you like to feel when it comes to a search experience? Because, I guess that the usual answer here would be like, you want to have an experience where you get specific results fast, you want to get useful information and all of that, but also, there are some other aspects very important to the search experience and to the e-commerce experience, which are related to privacy. You want a private overall experience. You don't want your data to be, treated without your consent or anything like that. And also you want a very usable experience. You don't want to get lost while searching or something like that. So those are, a set of ideas that here at Empathy we believe in. And these ideas are summarized in what I call the pillars of a search experience that are like, some ideas, some concepts that we all follow here when creating new products and all of that. Of course, there are many pillars. There are many things that, they conform, they build the base of a great search experience. But, in this session, we're going to talk about personalization, privacy, and then, relevance. So without further ado, let's start with the first of the pillars, which is going to be relevance. And we can define relevance as the quality or state of being closely connected or appropriate. But the thing about search relevance is that it is very important. It has a lot of impact over our customer experience, or it has a lot of impact over the sales that a business and e-commerce has online. And of course, it has a lot of impact over the growth of the same business. So it is very important to build an overall search experience that it's very connected to what relevance means. And of course, when I was preparing this talk, this conference, I thought I could give you lots and lots of theory about this and all of that. But I think that for the open source connections folks, I think it's going to be more interesting to see a bit of some demos, some products, some features that we build here at Empathy. And the first of them is going to be in-session context. This feature provides the user with more relevant results, and it does that by automatically detecting the intent of the user while searching in the same session in which they are in. And this is done without any kind of information transfer. The user doesn't have to do any kind of action like sharing their information or anything like that. So it's completely a privacy first experience. So as you can see here, I think you can see it well. We are in an unknown user. She's looking for some dress or something like that, something nice to wear, and maybe then she looks for some shoes, something like that. And then she realizes she's looking for another thing, another complement, which is a bag. And here is, let me pause this for a second. Here is where the funny thing begins with the in-session context, because as you can see here, I hope this is seeing well at home. But as you can see, we are suggested with a new kind of filter that is saying the user if they are interested in something like party, maybe something like that. And of course, if we select this kind of filter, the results are going to be changed, are going to be updated, so they are more relevant this time for the user and for the overall search in session that it's being produced in this context. So now let's talk about the second of the pillars, which is going to be personalization. And personalization is very crucial in a search experience because it is the act of tailoring, of making the results more suitable for the needs of a particular user, of a particular person that is buying in an online e-commerce retail store. And for that, we built this feature which is called affinities. And what affinity provides is like a new way of selecting your tastes, selecting your interests, and selecting your preferences while searching. And it does that by providing a new menu where the user can select their interests. For example, if you're looking for more casual clothes or something like that, you can select it, and the results are going to be filtered, are going to be personalized, so they are also more relevant to you. And we can see that in our example here. Let's make the same query again. Let's look for a dress. And right now we are in a anonymous user. But of course, in this demo, we have several users, and we can change between them. For example, if we want to see the affinities from Martha, she has set up some kind of affinities there where she selects like she wants minimalist styles or something like that. And of course, if we change again to another user, which is going to be Anna in this case, again, the results change because the affinities are different. And we select all of that in the menu provided by this feature in our search ecosystem. And now, let's go for the third of the pillars here. And I really like this illustration here, because I believe it represents perfectly the idea of, we have to get from the user what we really need, instead of getting all of the information, instead of treating all of the data available from the user, we can select to only choose, what the data that we really need. So I really like this illustration to hope and to, help you realize that idea. But, let's first start by defining what digital privacy is, because, the European Data Protection Board, they define digital privacy as the protection of individuals with regard to the processing of their personal data in the digital context. It encompasses the right to determine when, how, and most importantly, to what extent personal data is shared with others or made accessible to others. And all of these words are great. All of this theory sounds amazing in the paper, in the text, but the real scenario that we get in the most of the online shops, in most of online websites and all of that, is that we get constantly bombed with lots and lots of cookies that they aim to track our activity, they aim to track our data, and they aim to sometimes to share that data with third parties without our consent. And of course, don't get me wrong, I'm not saying that all of the websites do all of these bad intentions, but what we try to say with all of these is that online shops should ensure data transparency policies and things that are very needed for users nowadays. And for that, to illustrate a bit of the privacy first designs that we create at Empathy, I'm going to show you a demo about purchase history. But first, let me explain a little bit what purchase history is, because apart from the search main product that we have here at Empathy, we also have this purchase history product that, instead of taking as source of truth the catalog of the store, it takes as source of truth, as the name says, the history of purchases of the user. And in this case, we created this kind of branded IKEA demo, which shows a privacy-first design for purchase history, where all the data is stored in the local storage of the browser, instead of any kind of third party or database or whatever. And as you can see here, we can check all of the purchases from the user. We can search, of course, over them. We can see all of the information regarding them, and all of this data is stored in the local storage of the user itself. So as you can see, we can search for Mikey, which seems to be like a desk or something like that, and we can obviously process or buy again, upcycle, or do whatever the actions that we want to do over that specific item. So I think this illustrates perfectly the idea of privacy first experience in the context of purchase history. And of course, all of these ideas that we have seen, they were all present in each of the demos. Like the first one of them, the affinities, the in-session context, also the privacy first version of purchase history, they were all taking parts of each of the pillars of relevance, personalization, and privacy first. And of course, this is because we envision these ideas, these products, to be transparent to customers, to obviously build trust, respect obviously their privacy, and most importantly, ensure findability while maintaining high relevance, of course, and to provide ownership by empowering the user with controls like we did with the affinities demo. So I think they are really cool ideas regarding all of this search ecosystem that we have in Empathy. But of course, I'm going to talk to you a little bit now about open innovation, because what is open innovation? And I recently read this book that was called, a friend of mine gave it to me. It was called Still Like an Artist, from Austin Kleon. And I really like the idea that this guy said about no idea is coming from nowhere. Like all of the ideas that we have come from the building process of older ideas that we had in the past or that we found out about, and we built all of that into a new idea, a new innovation that we